right, what is the amplitude of this graph? It is 1. Yep, and we know that because, well, it's just there's a 1 in front of that secant. Sorry. All right. What is the period? 2 pi. Yep. What is the horizontal shift? 0 or none. Yep. What is the vertical shift? Same thing. Yep. 0 or none. All right. What are 2 consecutive asymptotes? Pi over 2 and 3 pi over 2. Yep, I think it's what I actually used. Pi over 2 and 3 pi over 2. And then, of course, if there was a horizontal shift, would these asymptotes change? Heck yeah, they would. All right. What is the range? Go ahead and type it in chat. If you think you know the range, I want it in interval notation. That involves that union symbol. Remember, it's least to greatest. So negative infinity to -1, union symbol. 1 to infinity. Perfect. And the ones have brackets because those are solid points. The infinity symbols always have parentheses. Nice job, everyone who wrote that in chat. So I'm just going to use my pointer. So again, range is your y value. So this graph goes to negative infinity. And then the highest point it goes to would be at -1. And that's why we have it go to -1. And then there's a gap from -1 up until +1. So there's your union symbol, your gap. And then +1, and then it goes to infinity. So that's why the range is what it is. It is important that all of you understand what this means and how to interpret it, whether you're looking at a graph like this or you're looking at the actual, well, notation. And then I asked you to do the same thing for this graph. And of course, graphing it in GeoGebra is going to be very, very helpful. But right off the bat, without graphing it, you should be able to pick out pretty much everything, right? The range may not be as easy to pick out without seeing it on a graph, but it's still definitely possible if you understand. The range is really based off your vertical shift and your amplitude. So the amplitude for the secant, if you graphed this next graph, the amplitude determines how wide that gap is, right? And you can see that from the graph. And I really hope all of you right now in chat have already graphed this to see that. And if you're watching the recording, you're doing this. Also, I keep sending like emails to people and putting comments in your TGA from last unit. Come to the live sessions. I say a lot of things maybe like before the recording or even after the recording that might be helpful for like a quiz or a test. And really, I don't know how you could fully learn this material without coming to live sessions. Because I'm getting these late submissions I'm getting from a lot of people. It's clear to me you have no idea what's going on in this class, and it concerns me that you're trying to learn this stuff overnight, and it's just not possible. So if you're watching this and you're not going to live sessions, get caught up and start coming. It'll change your math life, and it's not that bad. All right. Anyway. Also, with that said, look, I have like asterisks next to the bell work. Usually when I put stars or asterisks, especially in the titles of slides, it's kind of important, right? In this case, it's important because this is going to help you on your TGA for this unit, which is Tuesday. Well, Tuesday is part 1, Wednesday is part 2. So your TGA for unit 3, it's going to help you on number 3 of the TGA. I know, I should put the Mario star. But I thought three asterisks easy. All right. Looking at this one, what is the amplitude for this one? Amplitude is 2. Yep. What is the period? 2 pi. Yep. What is the horizontal shift? None. Very good. What is the vertical shift? Down 1. Yep. And you can also write the vertical shift as y equals -1. On your quiz, on your test, you actually may see it written like this. They may say down 1. They also may give you the horizontal line formula, y equals -1. The reason why they do that is the vertical shifts determine the midline of your graph. So in this case, at y equals -1, that's the horizontal line. That's where basically you have your reflection over in a way, but not a true reflection. Not a true reflection. But that is the midline. And again, from the midline to a min or a max, that is your amplitude. All right. And then just like the last problem, because we don't have a horizontal shift, the 2 asymptotes are going to be the same. All right. In chat, go ahead and write the range. Let's see it. I wish chat would show me like a ... of people who are in the process of writing stuff so I can actually see who's actually doing this. And I'm not waiting here for nobody. All right, so one person says -infinity to -3, union 1 to infinity. All right, so here's my question. People who did this, did you graph it in GeoGebra to see your range, to see if you agree with it? So Emily, I'm going to pick on you. Yeah, you didn't graph it. So Emily, you would be correct if there wasn't a vertical shift. I'm scared for lag. Lag is real. Are we supposed to use GeoGebra on the? Yes, I highly encourage you to use GeoGebra. Now, if you want to graph it by hand, knock yourself out. I think it's really good to learn it, but I also want you to be able to use the tools that you have. So, like when you're if you're in person in high school or in college, at least for this class, it would probably be required that all of you have a graphing calculator, and in that class, the teacher would show you how to actually graph some of this stuff. Like you can actually graph this on like a TI-84, for example, and then find out some neat stuff. So yeah, since you're working from home, of course, you can use your GeoGebra or Desmos and do the same thing. All right, so because of the vertical shift and the amplitude being 2, the range is in fact -infinity to -3, union 1 to infinity. Now, here's the important piece for your TGA. I will not give you the equation. I'm probably going to give you 2 consecutive asymptotes, like I did here. I'm probably going to give you the range. I'm going to tell you if there is a horizontal shift. I'm going to tell you if there is a vertical shift and how many. I'm going to give you the period. And I am not going to give you the amplitude because you can derive the amplitude from the range. So from -3 to 1, that is 4 units. And half of 4 is 2. That's your amplitude. So if you understand what amplitude is, the definition of it, and how it's the distance from the midline to a min or a max, that's your amplitude. And knowing that the range, that gap, at least for a secant and let's say cosecant, that gap, well, half of that distance is your amplitude. So I'm giving you plenty of help for your TGA number 3. And people that are here, great. People who are watching the recording, I really hope you didn't skip over this, but I don't know. We'll find out. Yeah, I think this is very doable. I went over this on purpose because I couldn't find anywhere in your modules or your quizzes where it presented a problem where it gave you information and it required you to derive the equation. Anybody who's gone through the modules, have they found a problem like that? Can we do an example where we do create an equation? Yeah, how about tomorrow? How about tomorrow for bell work? I'll create one. Yeah, I can't really create one on the spot because I actually got to think about what I want to do. And it takes me about probably 10 minutes to think about a good problem. So tomorrow morning for bell work, we'll do one of those, okay? All right, let's go on to today's lesson now that we spent the last 15 minutes doing that. All right, this is day 3 of 3.03 transformations of functions. So we're going to graph transformed trig functions. This is really the same thing as yesterday, so just more practice, which is a good thing, right? We're not necessarily learning more. We're just kind of practicing what we learned yesterday. All right, paper, pencil, GeoGebra. All right. So when graphing a function such as this, we want to think about the following. So the parent function, I think this is the most important. You need to know what the original problem looks like, whether it's y equals sine of x, y equals cosine of x, y equals tan of x, or the other 3 trig functions. So that's important. Just like in bell work, you want to identify all of the transformations. So, you should write down what the amplitude is. You should find the period. Remember, there's a formula for period. Do you recall what that formula is? Go ahead and write it in chat if you do. It is 2 pi over k. Yes, period is equal to 2 pi over k unless it's tangent or cotangent. And then, like Antonio says, it's period equals pi over k. So, yep. So that's important to know how to find the period. And then we need to know how to find the horizontal shift. And don't forget, I think we did 2 examples yesterday where we had to take that constant c and divide by k when k wasn't 1. So that's important to remember. And then, of course, knowing your vertical shift, well, that's the easy one. All right. So let's do this first one. What is the amplitude of number 1? Amplitude is 9. Yep. All right. What is the period? I'm going to give you all a moment to calculate it. When you think you have the answer, go ahead and write it in chat. Pi over 4. Yeah, that sounds good, I think. What was the setup? How did you calculate to get that answer? What was your setup? 2 pi divided by 8. Yep, and k is 8. Yes. So we took 2 pi, we divided by the k value, which is 8. And then we simplified this fraction. And we want to leave it in simplified form with pi in there. Yep, so pi over 4. So in your words, just anybody just write out in just quick words. What does the period do for one of these trig functions when you graph it? What does it do? Frequency. What do you mean by frequency? It tells us how long before it repeats. Yep, short and sweet. I like it. It tells us how long it is before it repeats. Yeah. So for this one, if we were to graph this in GeoGebra, it would repeat every pi over 4. So it's pretty quick, right? It does a full rotation of whatever this graph looks like, and it repeats every pi over 4. It's pretty quick. Pretty fast. You could even say it's almost 8 times faster, right? 8 times faster than normal. Yeah, it's pretty fast. All right. So in your quiz modules, you may see, rather than ask you for horizontal shift, it may use the word phase shift instead. It means the same thing. I don't think it was clear when it switches from saying horizontal and phase. It's not clear that they are the same, but they are the same. Phase and horizontal shift are the same, if you're wondering. All right, and yeah, phase shift is none or 0, and vertical shift is 1. Yeah, up 1. You may also see it written as y equals 1. So you may see it goes up 1, or it's y equals 1. And that's the horizontal line through the midline. All right, let's give you, I think 2.5 minutes for these 3 problems, or 3 minutes. What do you want? 3 minutes? Okay, 3 minutes it is. 3 minutes. Ready, go. Don't forget, locking date for Unit 2 is this Sunday. I know I've emailed at least twice about this and put an announcement up. But at least you guys can't tell me you didn't know the locking date was this Sunday, right? Worst excuse ever. Yeah, well, online school, your dog can still eat your laptop, I guess. Can anyone else see that line? What line? Let me go back and then forward again. Maybe it'll go away for you. Okay. Yep. New row. It's awesome. It's so feature jam packed. I can't even express my joy. We got another 40 seconds left. And yes, Dianica, you can do the number 2 on mic when time runs out. Hey, wait, now you're bashing New Row? I would never bash New Row. I think New Row is a great quality piece of technology that has come a long way. And there's still a lot of growth, and I can't wait to see what the future has in store for it. Oh, time's up. That can be difficult sometimes, whether I'm being serious or not. I'm mostly always serious. Most of the time, I think. All right, Danica, on mic, go ahead and tell me what your amplitude is.
The amplitude is 7.
Ooh,
and then
nice job.
for the period, I got 2 pi over 3, and I put it in the calculator, but it didn't keep it in like where pi is in the numerator, so I left it like that.
Okay, so question for you: what calculator are you using?
I actually don't have a calculator. I'm using an online calculator.
I thought you were getting that.
My dad won't buy me one.
I'm going to have it with me.
All right. Phase shift, what'd you get?
I got 0, and then for vertical, I got up 5.
Very good. Excellent. All right. Number 3, volunteer. Oh, Danica, you need to get a job by your own. Oh, wait, you do have a job. Yeah, buy your own. You should buy your own. You know what, Diana? You have a job. Invest into your future. You know, rather than buy a Starbucks for 2 days that will equal more than what you'll pay on this $12 calculator, buy a calculator. Anyway, and by the way, all of you should be able to buy your own cell phone and pay for your own cell phone bill. Everyone whose parents pay for your cell phone bill, you're spoiled. Anyway, kids these days. All right, who is doing number 3? I forgot. True, Chloe, true. All right, Emily on mic, go ahead and tell me what you got.
Okay, so for amplitude, I just got 3 because that's the number in front. For period, well, there's no coefficient, so it's just 2 pi.
Very good.
For the horizontal shift, I got negative pi over 4 because it's a plus sign, so the standard form is x minus, which would make it a negative. So that would be left pi to the pi over 4.
Perfect.
And then vertical shift is down 2.
Excellent. Nice job. Nice job. All right, number 4, volunteer. All right, Julia, go for it.
Okay, so for the amplitude is 1 over 4. The period is 2 pi because there's no coefficient. the phase shift
Wait.
is right pi over 2.
Wait, Julia, let's back up a second. Let's back up. What's your period?
Period is 2 pi.
Did you graph it?
No.
All right. So, okay, so we'll skip period.
Okay, I think I forgot something.
Maybe. Maybe. So let's go on to your phase shift. What did you get?
I got right pi over 2.
Very good. And your vertical shift?
And vertical shift up 3.
Perfect. All right. So the only mistake that you made was your period. And I think that if you would have graphed it in GeoGebra, you would have seen it. Are you typing in right now? There's a lot to type in. Yep, Julia. So, Julia, what does that tell us? Because it's a tan function. Yeah, and I think Antonio, I think you should use those formulas to find your period, but you have to know which one to use and when. Yep, Julia, you are correct. Yeah, the period is pi. So all the trig functions have a period of 2 pi for the parent functions, except tangent and cotangent. Those have a period of just pi. So on your test, you may have questions that ask you for the period, for example, and everyone who takes a test, you are, for each problem, you're given it randomly chooses from a pool. Oops, sorry, I hit my mic. A pool of questions of what you're going to answer. So theoretically, every test for every person should be different. And there might be a repeat question here and there, but overall, it's a different test. Well, I did look at that test, and some of the variations when talking about period, some are cosine, some are sine, and some are tangent. And if you're in the habit of putting 2 pi and you get the tangent problem, you might miss it just by bad luck. And people who would have got that same tangent problem would have also missed it, but because they didn't get the tangent problem, they got one that's just, more common, 2 pi period, they got it right. So be careful is the moral of my long story. All right, we good? All right, how much time do we have? We're doing pretty good. We're on page 8 of 12, if you're wondering. All right, so graphing. All right, so midline is y equals 0, and then that will be changed if there's a vertical shift. Yep, we know that. We didn't know the period because that's going to tell us how squished our graph is going to be or how stretched it's going to be before it starts to repeat. So that's important. Having a good starting point. So for like sine and tangent, starting at the origin, the parent function, that's a good starting point. And then for like cosine and cotangent, maybe starting at pi over 2 comma 0 would be a good starting point. And this is because these are the midpoints, right? If you were to graph this. All right, and then obviously, any asymptotes, make sure you know where those are at for these different functions: tangent, cosecant, secant, and cotangent. All right, so let's look at this one together. All right, so y equals 3 sine of 2x plus 1. And of course, on your quizzes, on your tests, I hope and expect all of you to not only calculate, the amplitude, period, the phase shift, and vertical shift by hand, but I also want you to type it into GeoGebra and see what you get. All right, class. Volunteer, want to tell me the amplitude for this one? Oh. Chat works too. Yep, 3. 3 is correct. All right, chat, what is the period? Period is in fact pi, yeah, because we took that coefficient, that k, and we took 2 pi divided by 2, and that's how we got pi for the period. So that means that our graph is going to be squished in the horizontal direction. All right, and what is that phase shift? 0, yep. And then the vertical shift? 1. What about 1? Be specific. You can say y equals 1 or up 1. Yep. All right. All right. So for the sine, we'll start the origin here. We'll graph this point. So we are going up 1. So I'm going to graph that new point up 1. All right, so there's my first point. All right, I'm also going to graph my last point in this cycle. So let me point to on the parent function, the point I'm talking about. So I graph this point, and then we do the cycle, and then the cycle starts over starting here. So I'm going to graph this point next. Now, so we know we have to go up 1, but because of the period is no longer 2 pi, it got squished down to pi. So that point gets plotted at pi comma 1. Pi comma 1. So that's going to go right here. All right, and now halfway between there, that is going to be where the graph is going to cross the midline. And then we're going to have the amplitude that is, amplitude is 3. So we're going to go up 3 from the midline. So from this midline here, between these 2 points, we're going to go up 3. 1, 2, 3. So there is this point. And then I'm going to plot the other one that is going to be down 3 from the midline. 1, 2, 3. And then I'm going to just connect the dots in a wavy motion, the best that I possibly can. And hopefully it's good enough. I'm just going to draw one phase, but then it would just obviously keep going, right? But I'm just going to draw that one phase. And then we can go into GeoGebra. And I want everyone to go ahead and graph this function and confirm that my single phase, or sorry, it's not, I don't think it's called a phase. It might be this one period rotation. I think it's called a phase, a one phase cycle. I think that sounds right. Smoother than a fresh jar of Skippy. Oh, yeah. All right. All right. Any questions on this number 5? Well, pretty simple, I hope. Especially when you have GeoGebra to confirm your answer. All right. Everyone tried this one. Let's give you... let's try 2 minutes. That's probably more than enough. 2 minutes, and then I'll take a volunteer to not only tell me the parts of it, but also graph it. It's a lot of sugar, everything you're describing in chat. Better watch out, you can get diabetes. Nutella's good. Balance is the key, Chloe. You were right. Yeah. Oh, gross. Eating Nutella by the spoonful. It's too much. Too much. I got another 45 seconds left. By the way, these are actually your TGA questions, not the exact questions, but yeah, like number 1 and number 2. I'm gonna give you a function. I'm gonna say graph it and tell me the parts of it. Super easy. It's honestly an easy TGA. The only hard problem is number 3, but we went over it on the bell work. So yeah, if you can do these, you can do the TGA, no problem. Oh, time's up. All right, volunteer, want to take me through this problem? All right, Antonio, let's do it.
Okay, so the amplitude is 2.
Yeah, I think you're right. Nice.
Here it is going to be pi. Phase shift's going to be pi over 2 to the left, right, to the right.
Good.
And then vertical shift down 1.
Perfect.
Okay, so I'm going to start here.
All right, so this is what I want you to do, Antonio. I want you to plot me 2 asymptotes, 2 consecutive asymptotes, and then I want you to plot the starting point, just one point of the tangent, and then just do your little wave or whatever.
Okay, so this first, hold up, you can't see it. This is pi over 2, correct?
Yes.
All right, so one's going to be right. That was horrible, but one's going to be right here.
You should use a different color other than a black on a black graph. It's easier to see.
All right, let me switch out then really fast. I'm going to use red. That works.
Okay, so for people who's colorblind like me, it looks black. That's cool too.
Okay, we're going to use green.
Okay, I think green's a better choice. So, fun fact about, I think it's like 8% of the population is colorblind. Might be 8 or 9%. It's about that.
Then the other one's basically that, because I'm using this one as an example. This one's over to right here, so that's why that's that. And then from there, it's going to go down 1. So that was there. You can move over 1 pi, move down 1. There's 1 point. And the other point's going to be...
You don't need other points. You just from that you can just do your graph. I don't want you to. You don't need to do another one.
So just a squiggly line then.
Yeah, the best you can. So yeah, for on your TGA, if you have like a tangent or a cotangent one, I want to see you graph 2 asymptotes and then that point, and then do your best to do a graph like that.
How did I manage to choose 2 colors that are black?
Or you can use GeoGebra and just like copy paste that into your TGA as your graph. I'm okay with that as well. It doesn't bother me. But I do need you to somehow identify your asymptotes in like a point or 2 or whatever. All right. Everyone agree with Antonio's work? I do too. I think it's pretty good. Pretty good. I think it's easy to see that he had a horizontal shift. So he moved this asymptote and this one to the right, pi over 2. And then he took this point. He went right, pi over 2, and down 1. So that's what he did. Very good. All right, so number 7. This is actually, I think, this is the last one. Yep, this is the last example. So we have time. We have a little bit of time left. So let's do. So I gave you 2 minutes last time. Was that enough time? Is that perfect? Yeah. Okay, we'll do 2 minutes again. Ready to go. I think Unit 3 isn't as bad as I thought it was going to be. Hopefully all of you think the same thing. It's not as bad as it seemed at first glance. I hope Unit 4 feels the same way, because it's long. True. Yeah, they weren't too bad. I'm really having my doubts about Unit 4, though, on some of them. But we will see. Another minute left. Any volunteer like to do this one after time runs out? Got another 30 seconds left. You hate the midterms? Yeah, the midterms next week. You're right. Worst time of the semester. Next week? Question mark. Do you not read my announcements when I post them in the course homepage, and then my emails that I send out? Do you? None of you read my email? I even put bullet points just to make it like easy to read. Yeah. So people who delete my messages because they have me as spam. Next week, tomorrow is the last lesson of this unit. On Monday is the review for Unit 3. Tuesday is going to be part 1 of Unit 3 test. Wednesday is part 2 of Unit 3 test. Thursday is going to be the review and the test for your midterm, also called the interim. And then on Friday, we are starting Unit 4. Next week sounds rough. Sounds rough if you're behind. So just like last unit, was that midterm really that difficult? It was multiple choice, A, B, C, or D. There wasn't fill in the blank. There wasn't type in your answer. It was 30 questions. It'll be 30 questions again. But really, if you know what's going on in this class, it's a test that's going to boost your grades. Like last term, it boosted almost everyone's grades. The ones that it didn't boost are the ones that are chronically behind and are getting through this course by nefarious means. I don't know. Which kind of leads us into my next question. Well, I'll talk about it at the very end of this lesson. Let's finish this. All right. Who wants to do this? Number 7. Somebody new? We got people in chat. Be new? Don't be scared. Whoops. You guys kill me. All right, Julia, go for it. I was hoping somebody new that hasn't volunteered would step up, but it's okay. All right, Julia, go ahead and tell me what you got for the stuff.
Okay, so the amplitude is 3. The period is pi. Sorry, it's pi over 2 pi. The horizontal shift is to the left pi over 4, and the vertical shift is down 1.
All right. So I would probably graph your asymptotes first. By the way, this is pi over 2, and this is pi. So pi over 4 would be halfway between 0 and pi over 2. So yeah, hopefully that helps. Julia, still there? I don't see anything on the screen yet. Okay, you're working on it. All right. Thought maybe your new row crashed or something. Oh, whoops. I think I messed that up. Oh, wait, no, I didn't. It's good. Oh, nope, I did. So this is one reason why you want to graph your asymptotes first. So I was trying to help you out by doing your asymptotes, and I put them in the wrong spot. I think that's pretty good. The only thing that I would change about this, I know it's hard to graph on Neuro, would be to make these two lines here going to infinity, hug the asymptote better on the edges. As it gets closer, just hug the edges. And then same thing for, well, this was kind of the end, so this is probably fine. But yeah, it gets really close to the asymptotes, but it doesn't actually touch it. But other than that, I would give credit for this. I think it's okay. All right, all of you agree with that? I'm guessing you all checked in GeoGebra and like it. All right, so on your TGA, I would really recommend graphing your asymptotes first with the phase shift. I think it really outlines where your graph should be versus drawing them after the fact. But nicely done. All right, so just a little closure, kind of final thoughts. Remember, your amplitude is the variable A. That's in front. So here's the general form for the sine formula or equation here. Your period for sine is 2 pi over k. If it was tangent or cotangent, it would be pi over k. So that's important to remember. Your phase shift is, this is important too. If you have a coefficient other than 1 in front of this x, for your phase shift, you have to take this constant here and divide it by the coefficient k. So that's important, just like on the last problem that we did. And then your vertical shift is all dependent on what this is. Whether it's plus or minus. If it's plus, it's up. If it's negative, it's down. And other than that, yeah, you want to see what the parent function does and then just do your shifts accordingly. Not too bad. And I think one unwritten thing is to check in GeoGebra.
When is it going to be pi over k again? If it's tangent and what? For the period.
Correct. Yeah, so the period is going to be pi over k when dealing with tangent and cotangent trig functions. And today is the quiz, yes. All right, any other questions? All right, well, as always, guys, I hope you learned something, and I will see you tomorrow. Tomorrow's Friday.